March 2021, paper 4, variant 2. Question 1. Figure 1.1 shows a piece of glass of thickness 2 centimeters and area of 0.15 meters squared. The density of the glass is 2.6 times 10 to the power of 3 kilograms per meter cubed. Can I find the weight of the piece of glass? Yes, I can find the weight of the piece of glass. How can I find the weight? You need the mass, right? Okay, can I find the mass? Yes, the mass would be equal to the density times the volume. Mass would be equal to the density times the volume. What is the density? The density is 2.6 times 10 to the power of 3. And what is the volume? The volume would be the area times the thickness. Okay, times the volume, which is the area, 0.15 times the thickness, 2 centimeters. You need to convert these 2 centimeters into meters. So divide by 100, which is 0.02. 0.15 times 0.02. Can we find the mass? Yes, we can find the mass. 2.6 times 10 to the power of 3 times 0.15 times 0.02, 7.8 kilograms. Can I find the weight? Yes, weight equals mg. 7.8 times 9.8. 7.8 times 9.8, which is 76.44 or just 76 newtons. The piece of glass shown is used in a vertical viewing of a window of an aquarium. The atmospheric pressure outside the aquarium is 1 times 10 to the power 5. The average pressure inside the aquarium window is 1.3 times 10 to the power 5. Inside the aquarium, the average pressure is 1.3 times 10 to the power 5. Can I find the resultant force and the direction of this resultant force? Yeah, I can find the resultant force. The resultant force would be force equals pressure times area. Right? You have the pressure and you have the area, but you can't use just one of these pressures. You can't just say, well, I'll use 1.3 times 10 to the power 5 or 1 times 10 to the power 5. No, you actually need the resultant force. You need the resultant pressure to find the resultant force. So first of all, the pressure, it's not 1.3, it's not 1.0, it's 1.3 times 10 to the power of 5 minus 1.0 times 10 to the power of 5, which is 0.3 times 10 to the power of 5 or just 3 times 10 to the power of 4. Okay, 3 times 10 to... So this is the pressure. Okay, this is the pressure. And then can I find the force? Yes, force equals pressure times area. Okay, and the pressure is 3 times 10 to the power of 4, and the area is 0.15 meters squared, so you do not need to convert it. 0.15, what's 3 times 10 to the power of 4 times 0.15? This is 4,500. So this is the resultant force, right? Resultant force is 4,500 newtons. In which direction is this force acting? You have, this is a window, right? This is an aquarium, so you have the water inside the aquarium, right? You have the water inside the aquarium. Which pressure is greater? Is the pressure inside the water greater or the pressure outside the water? He said that the average pressure inside the aquarium is 1.3, right? This is pushing outwards. And the average pressure from outside, which is just the atmospheric, is 1.0. The greater pressure would be the pressure inside the water, inside the aquarium. So the resultant force would be acting outwards. The resultant force would be acting outwards. Okay. Now, question C shows a vacuum pump. Pressure at point X is 9.6 times 10 to the power of 4. Can I find the density of the liquid? Yes, I can find the density of the liquid because pressure equals rho GH, right? Pressure equals rho GH. Density is the rho, so I want to find the rho, which is pressure over GH, right? Pressure over GH, or 9.6 times 10 to the power of 4. 9.6 times 10 to the power of 4 over 9.8 times the height, which is 12. We do not need to convert anything in this question. Times 10 to the power of 4 over 9.8 times 12, which is 816 kilograms per meter cubed. The density of this liquid. What is meant by a moment of a force? Moment of the force. It's the turning effect. Don't state the equation. When he says state the equation, you can't state the equation. But for this question, you need to say that it is the turning effect. Okay, turning effect of a force. Okay, about a pivot. Figure 2.1 shows a large crane on a construction site lifting a block of mass 14,000 kilograms. So the block is 14,000 kilograms. Can I find the moment about a due to... Okay, moment equals force times perpendicular distance. Force times... The force is the weight of the block. That's not 14,000 kilograms. You need to multiply it by... Hmm, it's 14,000 multiplied by 9.8. This is the force. And then you multiply by the perpendicular distance. Yes, it would be a huge number. Definitely, it would be a huge number. 9.8 times 20. Hmm. So it's 2,744,000 or 2.7 times 10 to the power of 6 newtons dot meter, right? Newtons dot meter. Speed is a scalar quantity and velocity is a vector quantity. State the difference between scalar and vector. Okay, so scalar, you have the magnitude, but no direction. Scalar, vector, okay, you have a magnitude and a direction. And the direction. Write down one other scalar and one other vector quantity. Other than speed, we can say mass. Other than, what did he say? It is a vector velocity. We can say, for example, acceleration. Two forces acting at an angle other than 90 degrees has been cancelled. This question has been removed. You're no longer required to solve this question. Okay. A power station burns waste materials from farm crops to generate electricity. State and explain whether this process is renewable or not. Biofuels, is it renewable? Yes. Yes. Why? Because the waste materials do not run out. Yes, because the waste, okay, materials do not, okay, run out. The power station uses some of its waste thermal energy to heat water for the houses in a nearby town. State one problem of using waste energy in this way if the power station is far from the town. So if the power station is far from the town, what would happen to the water? By the time it gets to the town, it will get cooled down, right? How can I solve this problem? How can I reduce this problem? By using insulation. The water will cool down. Okay, insulate the pipes. Okay, properly. State two environmental consequences of burning coal. Okay, to generate electricity. Coal, two environmental problems. You can say causes carbon dioxide pollution, air pollution, basically, right? You can say it's not renewable. You can say greenhouse effects, global warming, right? Non-renewable, and also air pollution. In terms of the momentum of molecules, explain how gas exerts pressure on the walls of a container. Okay, so gas molecules move fast and random in all directions, colliding with the walls, with the walls of the container, changing their momentum, right? Changing their momentum, causing a force, over an area, okay, over an area, which is pressure. And you can write down the equation pressure equals force over area. A fixed mass of gas, volume V1, at pressure P1 is compressed to a volume V2. Can I find the final pressure P2? Yes, the final pressure P2. We know the equation P1 V1 equals P2 V2. He wants to find P2. So P2 would be P1 V1 over V2, right? This is the equation. He just wants you to write down the equation. State and explain how the final pressure compares with P2. Is compressed to a volume. Compressed to a volume, right? What do I mean by compressed to a volume? Volume decreases. So what happens to the pressure P2? What happens to the pressure P2? It increases, right? It increases. Why does it increase in terms of molecules? Why does it increase in terms of molecules? You can say, okay, when the temperature of the gas increases, right? If the temperature of the gas increases, so you can say that the gas molecules gain kinetic energy. They gain kinetic energy. They move, okay, faster, collide with the walls, okay, harder and more frequently, okay? State the name of the reflection of a sound wave. Reflection of a sound wave is an echo. Figure 5.1 shows an ultrasound wave being used to scan an internal organ of a human body. The wave has a frequency of 2 megahertz. Mega is times 10 to the power of 6. And the speed is 1500. Can I find the wavelength? Yes, wavelength equals speed over frequency. Okay, wavelength equals speed over frequency. The speed is 1500. The frequency is 2 times 10 to the power of 6 because this is megahertz. What is 1000? Okay, divided by 2 times 10 to the power of 6. This is 7.5 times 10 to the negative 4. 7.5 times 10 to the negative 4 meters. It's a very small wavelength. Figure 5.1 shows crests of a wave from point S approaching a straight barrier. On figure 5.2 indicate and label one wavelength. One wavelength would be the distance, okay, between two wavefronts. Distance between two successive wavefronts. On figure 5.2, draw three crests of the wave reflected from the barrier. Okay, how can I draw the waves reflected from the barrier? First of all, you need to measure the distance between S and the barrier. Okay, measure the distance between S and the barrier, and then measure the same distance to the other side. So it's as if you have the same center on the other side. So you can call this point S or S dash or whatever. So this is the center of the waves, but on the other side of the barrier. Okay. Now, how can I draw? You need to draw using your compass, definitely. First of all, open up the compass to the first or to the last. I'm sorry, to the last crest. Open up your compass to the last crest. So you have the pointy edge at S, and then you open up the pencil all the way to this crest, and then flip the position, starting off at S at this point. Okay, starting off at S, you have the pointy edge at S. Draw the remaining wave this way. You draw the remaining wave this way. Why? Because it has the same wavelength. When you draw it this way, it will complete the wave, but it is kind of reflected in water. Okay, so this is the first wave. What should I do? How can I continue? How can I go on and draw these second and third waves? What should I do? You need to measure this distance. Okay, you need to measure the wavelength. You need to measure the wavelength. Let's assume that the wavelength is 1 centimeters. I think it was a little bit less. Maybe it was 0.9 centimeters or 0.8 centimeters. Okay, what do I mean by 0.8 or 0.9 centimeters? This means that I will keep on increasing the radius of my compass by 0.9 or 0.8 centimeters. So, for example, you measured the wavelength 0.8 or 0.9 centimeters. Now, when you opened up the compass all the way to the last crest, when you opened up the compass to the last crest, the distance or the radius of this compass is now around 3 centimeters, right? It's around 3 You will measure the compass or measure using your ruler, okay? Measure using your ruler the total distance. This is around 3 centimeters maybe or something. When you measure 3 centimeters and then you need to add a wave. How can you add a wave? So you'll add 3.8. I'm just assuming you should do the calculations on your own. Add 3.8, so it would be 3.8 centimeters. Okay, and then from this point, from this S, draw a wave of 3.8 centimeters this way. This is 3.8 centimeters. And then you add 0.8 or 0.9. Okay, when you add 0.8 or 0.9, you'll have another wave this way. So now we have three reflected waves. This question isn't that common, to be honest. Don't have that many questions talking about reflected circular waves. But again, here is one. So you kind of need to get used to it. You kind of need to get used to it. Okay, reflection of circular waves. Okay, figure 6.1, full scale diagram showing a converging lens. Principal focuses 1 and 2, F1 and F2. On figure 6.1, draw two rays from point O to determine the position of the image. Label the image IJ. Measure the image. Measure the length of the image. Okay. This is an object. It's already inverted and it's on the right hand side, which is not that common. But again, it's quite easy. I cannot even think about this question. This question seems to be too difficult. How will I be able to draw this image? It's a very difficult image. No, I will not. I'll just leave the question. No, don't leave the question. Can you flip the page? Okay. Can you physically flip the page if you have this exam printed out? Yes, you can. Flip the page. When you flip the page, now you have an object close to close to a lens, and this object, the distance between this object and the lens is less than the focal length, right? Distance between the object and the lens is less than the focal length. So if the distance between the object and the lens is less than the focal length, then you automatically know that the image will be what? That the image will be it will be a virtual image, right? It will be a virtual image. It will be upright and virtual, upright, and on the same side, right? Virtual, upright, on the same side. It's also enlarged, right? But how can the image be upright if the object is already inverted? Okay, so the image will be inverted. What do I mean? Is it? We also sometimes instead of saying upright, sometimes instead of saying upright, we say it's the same way up as the object. Okay, sometimes instead of saying upright, we say it's the same way up as the object. So basically, the image will appear somewhere on the right hand side. It will appear somewhat like this. This will be your image. Okay, let's go on. I want you to flip your page. Okay, just flip the page and start solving or start drawing the image. First line, how can you draw the first line? It's parallel, right? You have to draw the line parallel to the axes, and then from this point it would refract passing through the focal point, right? Passing through the focal point this way, right? And then the second line passes through the center. The second line will pass right through the center, undeflected, unrefracted, nothing will happen to the line, right? And they will not meet on the left-hand side. When you extend these lines backwards, now when you extend the lines backwards this way, they will both meet somewhere on this side, which is your image. So this is the image. Again, you're drawing a lot more accurately than me, but the image should appear somewhat like this. So this is the image IJ, right? This is the image IJ. That's it. This is the image. The image length should be around, the image length should be around 3 centimeters. Okay, plus or minus, plus or minus. So this is 3 centimeters. It could increase a little bit more, it could decrease, no problem. Ring 3 descriptions of the image. This is a magnified image. This is a virtual image. And as I said, it is the same way up as the object. So the object is facing downwards. The image will also face downwards. Figure 6.2 shows 3 rays of green light passing through the glass blocks. Green light. 3 rays of red light approach the glass blocks on the same paths. 3 rays of red light. Red. If red is passing in a prism, okay, and it was initially on the same path as the green light, what will happen to the red if I zoom in a lot more? Because this question might be slightly difficult. If you zoom in a lot more, at this point, the red would be refracted more or less than the green, less than the green. So it would be slightly above the green, right? And then as it goes outside, okay, it's slightly above the green still, right? Slightly above the green. Okay, what about the prism? What about this prism? It's slightly above the green as well. When you draw it above the green in an inverted prism, it's actually below the green this way. Okay, so it's slightly below the green. Okay, so you have the red, and then as it emerges from the prism, they will both intersect. Okay, they will both intersect somewhere. Okay, somewhere after the point of intersection of the green. Yeah, so they will intersect, but they will intersect somewhere after the point of intersection of the green. Is it a must that your distance or your point of intersection would have the same distance as my point of intersection? No. Your point of intersection could be here, it could be here, it could be wherever, but it has to be after the point of intersection of green. Okay? Okay. Figure 7.1 shows a horizontal conducting wire XY between two opposite magnetic poles. Wire XY forms a circuit with an ammeter. Explain why the reading on the ammeter is zero when the wire is not moving. When the wire is not moving, why is it zero? Because there is no cutting. Okay, it's not cutting the magnetic field. It's not cutting the magnetic field. Wire XY is moved and there is a deflection on the ammeter. Okay, that indicates that that there is a current from X to Y. There is a current from X to Y. So as you moved the wire, there is a current from X to Y, right? Should I use Fleming's right hand rule or Fleming's left hand rule? Hmm. Should I use Fleming's right hand rule or left hand rule? Definitely right hand rule. Why? Because this is a generator. You are generating, you are inducing this current, right? So this is Fleming's right hand rule. So the first finger, the index, is pointing from north to south, and then you know that the current is moving from X to Y kind of into the page. The second finger, right? The middle finger is moving into the page. Therefore, the force, the thumb, has to be upwards. The force has to be to the top of the page. Force has to be to the top of the page. Why? Because they are all at right angles, okay? You can say that the, for example, current, okay, from X to Y, magnetic field, okay, from north to south, and then you can say that the force, current, and magnetic field are all, okay, perpendicular to each other, okay, perpendicular to each other. State what is observed on the ammeter when XY is moved in the opposite direction to B. If it moves in the opposite direction, what happens to the ammeter? It deflects in the opposite direction. okay, deflects in the opposite direction. The same direction, but with a greater speed, then you would have a greater deflection in the same direction, definitely. Okay? Define electromotive force. What is the electromotive force? Yes, it is the work done. Okay? Work done by, okay, you have to think about it this way. It is the work done by the okay, work done by the source, right? Work done by the source. In moving a unit charge around a complete circuit. Okay, so electromotive force is the work done by a source in moving, okay, a charge around a circuit. I know that the marking scheme might have a different solution or a different answer to this. Why? It's because they have slightly changed the definition of electromotive force, and they have slightly changed the definition of the electromotive force and the potential difference um, ever since. Okay, heater H has a resistance of 22.5 ohms. Potential difference across it is 45 volts. The EMF of the source is 60 volts if this has a voltage of 45 volts. Can I find the power of the heater? Yes, I can find the power of the heater. Power equals I squared R, or if you have the voltage and the resistance, it could be V squared over R. Okay, Anna, I do not like to do that. Can I say that power equals IV? Can I say that power equals IV? Yes. Can I find the current? Yes, I can find the current by saying V over R. You have the voltage 45 and the resistance 22.5, which is a current of 2 amperes. When you have the current of 2 amperes and the voltage of 45, so the total power of the heater is 90 watts. 90 watts. Can I find the potential difference across X? Yes, the potential difference across X. If the potential difference across H is 45, the total is 60 volts, right? 60 volts. If this takes 45, the heater takes 45, then these would take 15 volts. Total voltage has to be divided equally. 15 it's 60 minus 45. That's how we found 15 volts. Can I find the current in the 10 ohm resistor? Yes, I can find the current in the 10 ohm resistor. I equals V over R, right? I equals V over R. 15 over 10, right? 15 over 10, which is 1.5 amperes. That's easy. Definitely this page is all cancelled. Okay. Do not need to solve the page. Question 10. State the proton number, nucleon number, and the value of the charge on an alpha particle. On an alpha particle. Proton number, okay, 2. Nucleon number, 4. Charge, positive 2. That's it. Yes, 3 very easy marks. Okay. A nucleus of strontium-90 consists of 38 protons, 52 neutrons. Strontium-90 is radioactive and decays beta emission. Okay, to produce yttrium. Anyway, let's write it down. Strontium, how do I write strontium? Sr. Sr, it's 90 and 38, right? 90 and 38. It produces Y and a beta particle. The beta particle is 0, -1. So this Y has to be 90. What happens to the proton number? It increases by 1. Why? Because -1 plus 39 is 38, right? Half-life of radon is 56 seconds. The sample of radon is in a container. After 12 seconds. The mass is 9.2 milligrams. Calculate the mass of the original sample. Okay. Can I find the mass of the original sample? Yes. First of all, you need to say 112 divided by 56 is 2 lives, meaning that you have already divided by 2 times. You have already divided by 2 times. So basically, you need to multiply this mass by 2 times. What is 9.2 times 2 times 2? It would be around 36.8 or 37. Okay, 36.8 or 37 milligrams. So this is the original mass. Okay,